Okay, here's question number 4. A lot going on in this one. So again, this could be a good example for this year, putting a lot into one question. So we have our potato, boiled potato taken from the pot on the stove, left to cool in the kitchen. Internal temperature of the potato is 91 at time 0, and it's greater than 27 for all times greater than 0. And we have a differential equation that can find the temperature of the potato for us at any time. So, first, part A, write an equation for the tangent line to the graph of h at t equals 0 and use it to approximate the temperature of the potato at time t equals 3. Okay, for an equation of a tangent line, we need a point, which they gave us. At time 0, the temperature is 91, and the slope we just sub into our dh dt equation. So negative 1/4 times 91 minus 27 gives us negative 16. So our tangent line at the point 0, 91 is y minus 91 equals negative 16 times x minus 0, or just negative 16x. And we use that to approximate the internal temperature at time t equals 3. So we sub 3 in for x. So y minus 91 is negative 16 times 3. So y is going to be approximately equal to 43 degrees. At time t equals 3, the temperature is approximately 43 degrees. Okay, part B, use the second derivative to determine whether A is an underestimate or an overestimate. Okay, remember, let's think about this. Concave down, concave up. When we have a function that's concave up, the tangent line approximation is an under approximation. When we have a function that's concave down, the tangent line is an over approximation. So we start out and we say, okay, our second derivative is going to be negative 1/4 times dh dt, because the derivative of h is dh dt. So that means it's going to be negative 1/4 times negative 1/4 of h minus 27, which is 1/16 of h minus 27. At our point of tangency, when we put in 91 for h, we get a positive number. So that means our second derivative is positive, which means h is concave up, and our approximation is an under approximation. Okay, part C, we have an alternate model for the temperature, dg dt. We want to find an expression for g. So basically we're solving this differential equation. dg dt is negative g minus 27 to the 2/3. So we separate. We get dg over g minus 27 to the 2/3 equals negative dt. Integrate both sides. Before we integrate, I would rewrite the left side as g minus 27 to the negative 2/3 dg is equal to negative dt, integral of both sides. And then the left side, yes, it's a u sub. I did not write out the u because du equals dg. So we get g minus 27, add 1 to the 1/3 times the reciprocal of 1/3, so times 3 is going to equal negative t plus c. Sub in our initial condition of 91 and 0. We get 3 times 64 to the 1/3 equals c. Cube root of 64 is 4, so 3 times 4 is 12. So now we have 3g minus 27 to the 1/3 is negative t plus 12. Divide both sides by 3, so we get g minus 27 to the 1/3 equals negative t over 3 plus 4. Raise both sides to the 3rd power, so g minus 27 equals negative t over 3 plus 4 to the 3rd power plus 27. And there we go. There's g of t. And we want to find the internal temperature at time 3 based on this model. So g of 3, sub in 3, we get negative 3 over 3 plus 4 cubed plus 27. Well, negative 3 over 3 is negative 1. Negative 1 plus 4 is 3. 3 cubed is 27, and 27 plus 27 is 54.